There's been debate for a while among climate scientists, and especially those that consider themselves as climate communicators, that we should be careful about using words like model biases and projection uncertainties and so on, because the general assumption was that that scares people and that the deniers will use those to mislead people and so on. But does it really make people trust us less, or does it make them realize that there are irreducible uncertainties in this business, that predictions or projections are never going to be 100% correct? And you make forecast, let's say at seasonal time scales, and there is a climatology, which is a long-term average climate, which has a lot of so-called internal variability. And even if your prediction is perfect, you may still be away from what happens on that particular day or in that season. So these are part of the business. So this paper is nice in that sense. It's a few years old, from 2019, and I'm recording it now in 2025 September, because this came up in a discussion I was having with one Udit Bhatia from IIT Gandhinagar. So I decided to go back and make a podcast on it because it's still very relevant. I talked about this paper at that time in my talks, but I wasn't recording any courses at that time. So, acknowledging uncertainty impacts public acceptance of climate scientists' predictions. Here we are saying predictions, but you will soon see that it's not just predictions. We are much more worried about projections as well. Predictions about the effects of climate change cannot be made with complete certainty, so acknowledging uncertainty may increase trust in scientists and public acceptance of their messages. So you have to basically say these are what if scenarios and not just guaranteed outcomes. Here we show that this is true regarding expressions of uncertainty unless they're also accompanied by acknowledgements of irreducible uncertainty. So there are irreducible uncertainties, which means even if we get all the data, all the AI, best models, because it's such a nonlinear system, it has emergent properties and things happen that we didn't expect or we don't expect necessarily, because we don't have a million years of everyday weather to say we have covered the entire range of possibilities, right? A representative national sample of Americans a representative national sample of Americans read predictions about effects of global warming on sea level that included either, so it should be read. Sorry, it's been a few days since I read the paper myself. A representative national sample of Americans read predictions about the effects of global warming on sea level that included either a worst case scenario, so high partially bounded uncertainty, or the best and worst case scenario, so fully bounded uncertainty, compared to a control condition expressing full bounded but not high partially bounded uncertainty, increased trust in scientists and message acceptance. However, these effects were eliminated when fully bounded uncertainty was accompanied by an acknowledgement that full effects of sea level rise cannot be quantified because of unpredictable storm surges. Thus, expressions of fully bounded uncertainty alone may enhance confidence in scientists and their assertions, but not when the full extent of inevitable uncertainty is acknowledged. So it's a bit complicated, but the main message is that we should acknowledge uncertainties and not overburden them with complexities that they cannot comprehend. People make decisions, especially farmers, let's say, or politicians. They have to make decisions, and uncertainty cannot stop them from making decisions. And as often pointed out by myself and others, politicians have to make decisions and win or lose elections. We give advice, and we are not always responsible for the outcome. So we have to be careful about berating the politicians for not taking actions and so on and so forth. So this paper actually did some experiments, did statistical analysis of the people's perceptions and then drew some conclusions. It's a nice paper, but I'm going to be supremely brief about it because my main point is that we are shying away a little too much from uncertainty, and that can have unintended negative effects on people's trust in us. So we must come out and admit uncertainties as and when necessary, but yet be careful about it, right? The study of global warming inherently entails uncertainty, which arises from the incomplete understanding of the climate system and its natural variability, the long time scale involved, and the difficulty of anticipating human activities, right? Putin does something, Hamas does something, Israel responds, rest of the world responds with Ukraine. So you have lots of things happening that affect emissions, food supply, fertilizer supply, generally transportation of ship routes, this, that, and everything else, which all affect climate change as well, right? Climate scientists routinely acknowledge such uncertainty. For example, in the 2000 IPCC report, they expressed uncertainty in various assessments. Acknowledgements of uncertainty are necessary to accurately and honestly depict scientific knowledge. However, uncertainty may have undesirable effects on trust and message acceptance in the general public, and then there are vested interests like the oil companies which can use it to mislead people, as I mentioned. Specifically, acknowledging uncertainty may cause people to hesitate before believing findings and thereby undermine the impact of scientific evidence. So evidence may be very solid but may come with some uncertainty, but people may overinterpret the uncertainty and just discard the whole thing. In fact, much research documents that acknowledging uncertainty can decrease message acceptance. People are more persuaded by eyewitness testimony and advice from experts when delivered with greater certainty, and this has happened quite common in the climate community, where many of the people, talking heads in the media, tend to be very certain, and their approach is that the end justifies the means. So if we ignore scientific uncertainty, they say it's okay because the end, the goal of mitigating climate change and reducing global warming, etc., are much more important. But people know that politicians tend to exaggerate and not depict uncertainties, and scientists' credibility is very high, but if they people see us also as wishy-washy, being wishy-washy about uncertainties, then it may hurt us overall, right? So when scientists describe their uncertainty about risk, this sometimes leads people to conclude that the scientists are incompetent. This is important and we need to avoid it. However, evidence suggesting that uncertainty undermines experts' claims may not generalize to situations in which complete certainty is implausible. One definition of being trustworthy is that a person's opinions are honestly based on available information. So if a source expresses unwarranted high confidence, this may undermine trust, right? You know one person now in the world who's supremely confident, and some people believe him, but most people just don't care. For example, extremely high confidence is hard to justify when predicting the future. When given a deterministic forecast of the weather, for example, of a low of 0 degrees C, more than 95% of the people infer uncertainty, anticipating that real temperature will fall in the range around the prediction. This is especially true for 30% chance of rain or partly sunny, partly cloudy, and so on. The same is true for financial predictions. If a natural scientist were to make a prediction without acknowledging any uncertainty, this might seem implausible to a thoughtful recipient of the message. In contrast, if a scientist were to make a prediction accompanied by an expression of uncertainty, the scientist may gain credibility for acknowledging his or her inability to know exactly what will happen in the future. So people are not fools, right? So uncertainty can be acknowledged in many ways. The IPCC's 4th and 5th assessment synthesis reports, remember this paper is from 2019. The latest CMIP 6 was released only in 21-22. So those reports contain various uncertainty expressions. You can look it up, or I have discussed them elsewhere. Many expressions accompany predictions with bounded uncertainty, meaning they specify bounds on the range of possible outcomes, 75th percentile, 25th percentile, and so on. Impacts and or timescales are also implied in these projections in a form similar to confidence interval around a prediction such as global mean sea level rise is expected to reach between 14 and 44 centimeters within this century. But this is global mean, so the local in your backyard sea level rise can be much more uncertain. Okay, but without specifying the likelihood associated with each of the bounds of the prediction interval, this uncertainty depiction is not complete. The research reported here examined the impact of acknowledging uncertainty in two different ways that have been common in science communications about global warming. One, fully bounded uncertainty. For example, global warming will cause sea level rise about 4 feet. Global warming will cause sea level to rise about 4 feet, but it could be as little as 1 feet. I'm losing my English. Could be as little as 1 foot or as much as 7 feet. There you go. This conveys best and worst case scenarios around a prediction. And secondly, high partially bounded uncertainty, which describes only a worst case scenario as high as 7 feet. Because low partially bounded uncertainty, a most likely future plus a best case scenario, is relatively uncommon in science communication, we did not examine the effects of such expressions. Basically, there is an ad hoc evolution of climate communication that is using uncertainties, in a personal way, almost individual approaches. There is no codified scientific approach to this so far. So the impacts of doing this have to be understood, which is the effort of this paper. Experimental design, bounded uncertainty can be none, so a single estimate, partial, so estimate plus an upper bound, or full, so estimate plus lower and upper bounds. So that's clear what we mean. So irreducible uncertainty, storm surge not at all mentioned, so no uncertainty. High partially bounded uncertainty and fully bounded uncertainty. So they are doing experiments and looking at number of people, so 192, 199 and 213. Storm surge mentioned, no uncertainty and irreducible uncertainty, high partially bounded uncertainty and irreducible uncertainty, fully bounded uncertainty and irreducible uncertainty. So even if you give an upper and lower bound, you can say you cannot reduce the error beyond some threshold. Okay, that are just irreducible. For example, sea level rise also has to account for land subsidence, which is not always done in all these things, right? In a long-term trend, you may kind of estimate land subsidence or rebound, but obviously not always. Okay, so just some examples. I won't read the numbers, but ordinary least squares regression coefficients predicting message acceptance and probit regression coefficients predicting trust in scientists. So we'll just look at the main rubrics. Predictor, dependent variable message acceptance, dependent variable trust in scientists. So the survey is used to do these calculations with statistical significance. High partially bounded uncertainty, fully bounded uncertainty, irreducible uncertainty, high partially bounded uncertainty times irreducible uncertainty, fully bounded uncertainty times irreducible uncertainty, constant and adjusted R squared. So statistical things which are very important because you want to understand what is the general perception of people with these different predictor types. So just let's jump to the discussion. It's a nice paper, but I'm not reading even 10% of it because I just wanted to carry this message at this time that we are dancing around a little too much about uncertainties, worrying more about climate deniers than about public trust in us. Okay, this study explored the impact of bounded uncertainty on trust in scientists and acceptance of their predictions and tested mediational pathways of effects in a nationally representative sample of American adults, which is a good country because there is a lot of confusion or denial or rational ignorance of climate change, whereas other continents and countries hardly suffer so much. In addition, it tested how bounded uncertainty expressions affect the public when they are presented with additional information illustrating that the consequences of predictions cannot be fully quantified and that uncertainty is thus irreducible. So even if your global mean temperature projection is very certain or much less uncertain, translating that into sea level rise or the model output for sea level rise can have much higher uncertainties because neither global mean temperature nor global mean sea level rise are very useful for people or governments because nobody lives in the global mean temperature or global mean sea level rise. So you need to know what is the local temperature rise and sea level rise and so on. So that's where all the uncertainties and trust have to be developed, right? So in addition, it tested the findings suggest that expressions of bounded uncertainty can improve acceptance of climate scientists' findings. In the absence of information about irreducible uncertainty, fully bounded uncertainty increased message acceptance because it increased trust in the scientists. So if you say upper limit, lower limit, fully bounded, people trusted it more if you don't mention irreducible uncertainties, because then people say, well, maybe they don't know what they're talking about. These effects appeared equally strongly among people with limited cognitive skills and those with strong cognitive skills. When you split people into these sorts of classifications, you have to be careful, because if you call people they have limited, tell them they have limited cognitive skills, then they may not take it well. Suggesting that uncertainty messages are easy to process and to use, resonating with other research. In other words, cognitive skills didn't change the perception and acceptance of uncertainty messages. Moreover, the effects of fully bounded uncertainty appear to occur regardless of a person's a priori skepticism towards global warming. That's good news. So people, it didn't matter whether they believed in global warming or not. The present research rebuts, I'm jumping ahead, rebuts the often heard claim that expressing uncertainty undermines persuasion. Lay audiences often operate on the assumption that acknowledging uncertainty acknowledges weakness. Lay audiences do that. Psychologists have found that uncertainty is aversive and that people are motivated to reduce it. So people don't like uncertainty, neither does nature, I suppose. Therefore, one might imagine that the public would turn away from experts who make claims while acknowledging their own lack of full understanding. However, people seem to recognize that complete uncertainty in future predictions is complete certainty in future predictions is not possible. Here, predictions and projections are used interchangeably, but typically we know predictions mean initialized predictions and projections anyway. Okay, so this is true especially in the context of global warming. Scientists who openly admit the limitations inherent in their predictions may bolster their credibility and as a result may increase the appropriate use of scientific findings by non-experts. Experts themselves have to understand how to convey uncertainty and not try to hide them or not be overconfident and be alarmist in many cases. These gains may be nullified or even reversed when scientists acknowledge that no matter how confidently they can make predictions about some future scenarios, the full extent of the consequences of those predictions cannot be quantified. So people want to have some sense that you are making projections with uncertainties but not completely useless projections. Optimal communication about climate change may involve presenting uncertainty that has predictable bounds without overwhelming the public with discussions of factors involving irreducible uncertainty. And there are other details. Up to what time scale are these projections really just about physics and internal variability and model deficiencies or biases versus the assumptions of scenarios and so on, which we have discussed elsewhere. So I think this is a useful message that there is no need to hide uncertainties, but we should find a way to put upper and lower bounds on them so that people can take the fully bounded uncertainties and especially politicians who may be skeptical or not, that they can make decisions despite the uncertainty. This is what we call post-normal science, where values may be contested, there are uncertainties, risk is uncertain as well, but decisions are urgent nonetheless. So we have to play our role in conveying our science with uncertainty and not try to hide uncertainties. Okay, let's leave it here.